Okay girls, so in the last video means part 1 we covered the topic and the relation V equal lambda f, where we discuss about frequency, wavelength and the speed, correct? So we got to know there that the speed will be faster in the solids, then liquids and then gas, correct? So here we have to start some questions based on it. So let's start with question number 16. It is saying, what is the speed of a periodic wave disturbance that has a frequency of 3.50 hertz, which is frequency, and the wavelength is 0.700 meter, so that is lambda, correct? So they are asking speed. What is the relation? V is equals to lambda f. Lambda value they have given you 0.700 and frequency is 3.50. When you multiply, you'll get this answer, correct? Now this question is a little bit tricky. Question 17. How does increasing the wavelength by 50% affect the frequency of a wave on a rope? So here they are saying if the wavelength is increased by 50%, then what will be the frequency of the wave? So as you all know that the frequency is inversely proportional to wavelength and vice versa, correct? So if the wavelength will be increased by 50%, it is increased by 50%, then frequency should be reduced by 50%, correct? So how we can calculate it? What is the meaning of that? So what we can do, we will take the condition. Let's say your lambda final is becoming 50% increased. What does it mean? It means initially it has let's say lambda wavelength lambda plus 50% of lambda is increased, correct? So you have to add 50%. So lambda plus 50%. 50% means 50 over 100 lambda, correct? So when you solve this, what you will get? Here is 1. So if you take lambda common, here it will be 1 plus the 0 will be cancelled out. This is 2 times. So it will be 1 over 2, correct? So when you add all this, you will get 3 by 2 lambda. Means your lambda final, when it is increased 50%, it is 3 by 2 lambda, okay? Or it is just, you can memorize. If anything you are increasing 50%, if you are increasing 50% anything, it will be becoming 3 by 2, okay? And when you are reducing, it will become 2 by 3, okay? So this is the trick. You can say 50% increasing, it will be 3 by 2. If 50% decreasing, that will be the answer for us. It will become 2 by 3, okay? So let's first see that. 50% increasing, you got lambda 3 by 2, okay? So what is the relation? Inverse relation. So what will be the frequency final? It is 1 over lambda f. It depends, correct? So it means the final lambda, what you got it, if you replace it with the value, what you will get? 1 over 3 by 2 lambda, correct? So this 2 will go up, so you will get what? 2 by 3. 2 by 3, yes or no? This is the frequency lambda f. So it becomes 3 by 2, so it will become 2 by 3, correct? So your correct answer will be 2 by 3, 2/3 of its original value. So you can do it directly, okay? This question you can do it directly by saying 50% increasing, it means 3 by 2. If 50% decreasing, it means 2 by 3. So if you have, it will take just a second to solve such question, okay? So if I'll give you example, if I'll say if it is increased by 80%, what does it mean? It is now not 50%. So 80% increasing, let's say I'm increasing 80% lambda. So what will be your lambda f? 80% increasing means lambda plus 80%. So 80 by 100 f. Sorry, lambda. So it will be how much? 180 over 100 lambda, correct? So when you solve it, you will get 9 over 5. So 9 over 5 times of lambda. So what will be the frequency? So frequency will be reduced by, just change the thing. It is 9 over 5, so it will become 5 over 9. So its frequency final will become 5 or 9 times of frequency, correct? So it's a direct relation. So whatever the relation of lambda it is coming, just do the reciprocal. Whatever the relation of frequency is coming, just do the reciprocal of lambda. So that's how you can solve the question easily. Clear? Now question 18. The speed of a transverse wave in a string is 15 meter per second. So they have given you V. If a source produces a disturbance that has a frequency of 6 Hertz, what is its wavelength? So they have given you frequency and they're asking wavelength. So what is the relation? Lambda is equals to V over F. V they have given you 15, F they have given you 6, and this is your answer. Correct? The next question, 5 wavelengths are generated every 0.100 seconds. So 5 wavelengths, okay, is generated in this much of second in a tank of water. What is the speed of the wave if the wavelength of the surface wave is 1.20 centimeter? This is the wavelength which is given to you in centimeter. You should convert into meter. Okay, how to convert into meter? 1 meter is equals to 100 centimeter. Correct? So 1 centimeter is equals to 1 over 100 meter. Correct? Or you can say 0.01 meter. Correct? So how you can convert this 1.20 centimeter into meter? You have to divide by 100. Yes or no? Once you divide it by 100, you will get that value in meter. Okay? So how you will get the frequency first? So frequency they have given you here. Frequency means the repetition of the work in every second. So here they have given 0.100 second. And how many wavelengths? 5 wavelengths. So you have to just inverse it. So you will get 5 over 0.100 second. So once you solve it, you will get 5000 hertz. Correct? Now you have to calculate time period. So time is equals to 1 over F. So 1 over 5000. Once you divide it, you will get 0.0200 second. Correct? This is what you got, time period. So once you got the time period, apply the formula V is equals to lambda by T. Correct? This relation from where you got it? The very basic formula. V is equals to, you have this formula also, you can apply the another formula also. V is equals to lambda F. Correct? Or frequency, if you put 1 over T, you will get lambda by T. Correct? Both formula is correct. So if you apply this formula with the time period, you will get 60 centimeter per second or 0.600 meter per second. So if you put the value of lambda directly over here in meter, you will get in meter. If you're not converted, you have to convert it before. Okay. So in this way you can calculate it. So don't forget to put the lambda in meter if you have to get the answer in meter per second. If they are asking in centimeter per second, no need for the conversion. Clear? So for the verification of the work, you can do it like here, lambda 1.20 over 100. So once you do in the calculator, just check it, what you will get it. It will be 120 and 40 will be here, this 22. So it will be almost this 00 will be cancel out and it will be 0.0012 meter. Correct? Just check in the calculator. Okay, so if you convert it before, it will be easy for you if you will do it. Correct? So this is how you have to proceed for this question. This will be 1000. So I think you will get only 0.012 meter. Okay, so if you put here 0.012 meter, you will get directly this answer, 0.600. Now the next question is a periodic longitudinal wave that has a frequency of 20 Hertz. F they have given to you along a coiled spring toy. If the distance between the successive compression is 0.600 meter, what is the speed of the wave? Now here they are talking about compression, spring, compression and rarefaction. So this is your spring, for example. This is the compression and their rarefaction. Then compression, then rarefaction. So this is compression, this is compression. So the distance between two compression is called wavelength, okay, or the distance between two rarefaction, that is also wavelength. So here they are saying the distance between two successive compression. So two successive compression, it means they have given you wavelength. They have not given direct wavelength, correct? They have given in words. So 0.600 is the wavelength, and they have given you frequency. So what is the formula? V is equals to lambda f. So lambda 0.600 and frequency 20. So once you multiply it, you will get 12 meter per second. That will be your answer. Now the next question is, how does the frequency of a wave change when the period of the wave is doubled? Now again the question will be like that. They are changing frequency and they are asked how does the frequency of a wave change? They are just doing double the period, correct? So what is the relation? F is equals to 1 over t. So time period, this time period they are making it double. So if they are making it double, what does it mean? It will be 1 over 2t. So what will happen to the frequency? Frequency is inversely proportional to the time period. So if it is getting double, so it will become half. Yes or no? This 2 will go up. So like that. So t will be frequency will be equals to what? Half of the initial frequency. Means if it is double, it will become half. Correct? So 1/2 its original value. So they are asking how does the frequency, here it's not correct, how does the frequency of the wave change when the period is getting double? So here this is frequency. So frequency is 1/2 of its original value. Describe the change in the wavelength of a wave when the period is reduced by 1/2. Again the question is tricky. They are saying wavelength, how the wavelength will get changed when the period is reduced to 1/2. So 1/2 means 1 by 2. Correct? So what is the relation of wavelength with the time period? Lambda is equals to, what is the formula of lambda? Remember the rule. Here it is V, here it is lambda, here it is F. But here they are talking about time period, correct? So with the time period, if you remember, I explained to you there is one more formula. V is equals to lambda over T, correct? So V is equals to lambda over T, or you can say lambda is equals to Vt. Yes or no? So what does it mean? If they are reducing the time period, okay, this time period 1 by 2, so what will be the change of lambda? So it is half, correct? So wavelength will also, because of direct relation, lambda is directly proportional to time period here. So if it is half, it will also become 1/2. If the speed of a wave increases 1.5 times to its original speed while the frequency remains constant, how does the wavelength change? So speed of a wave increasing 1.5 times. So speed and wavelength, what is the relation? Again the same concept. V is equals to what? Lambda F. So the relation of speed with wavelength, it is how much? It is directly relation. Frequency is constant, so V is depends on lambda. So if the lambda means the speed will increase 1.5 times, so wavelength will also increase 1.5 times, because they are directly proportional, correct? So if there is direct proportional, same relation. If it is not direct, inverse proportional, it will become half. So what is the trick, you can say? The trick is, if the direct relation, okay, so if x is increased by 2, okay, then y will also increase by 2. If it is an inverse relation, what does it mean? If x is increased by 2, then y will be increased by what? 1 over 2. It will become half, means if it is doubled, okay. So there are sentences. So if the sentence is like times, 2 times, 3 times, times means multiply, times means what? Multiply, okay, it will get multiplied, double, triple, all these are multiplication. But if it is saying increased by, decreased by, okay, so if it is saying increased by 2, what? Let's say x is increased by 2, so how you will write? X final will be x initial, plus it is increased by 2, so it will be added 2. Okay, if they'll say 2 times increase, so it will be x plus 2x, like that. Decrease by 2, it means xf will be x minus 2. Understand? If they'll say 50%, like before, x is increased by 50%, so 50% means x final will be x plus 50% of x. What does it mean? X plus 50% means 1 by 2, 50 over 100x, correct? So it will be, when you solve together, it will be 3 by 2x. So when you reduce it, it will become 2 by 3. Reciprocal, it will be just inverse, correct? So these are the small language base of questions which you should understand and stick into it. The next question is, a hiker shouts towards a vertical cliff as shown in figure. The echo is heard 2.75 seconds later. What is the speed of sound of the hiker's voice is in air? Here you have to be very careful. Here they are talking about speed. So what is the general formula of speed? Distance over time. So here the distance is, it is heard 2.75 seconds later. So what is actually going on? In the figure it is going 465 meter and it strikes back to its the same distance, correct? 465 plus 465, you have to add, or you can say 2 times of 465. This will be the distance total. So here you can see the distance, they have written this, and the time total they have taken 2.75, and this will be your answer. The wavelength of the sound is this 0.750 meter. What is its frequency? So the formula of frequency, v is equals to lambda f. So f is equals to v over lambda. Velocity you have already calculated from here, and wavelength they have already given to you, correct? Calculated, you will get 451 hertz for frequency, correct? The third is period of the wave. So period is time is 1 over f, because frequency you already got it. So frequency, once you put in the formula, you will get the answer of time period. So here the basic concept is, you have to take not a single distance, you have to take the total distance going and coming. Now the third objective is, describe that a mechanical wave is inverted if reflected from a fixed end and remains upright if reflected from a free end. So what does it mean? Actually, if this is the wave, okay, and it is going through it like this incident, and this is the some kind of barrier, so when it hits here, it will get back. So always remember, if it is going with the crest part, it will come with the inverted, like a trough, correct? So this is called pulse. This is called what? Pulse. This shape is called pulse. So once pulse is going up, then after reflection, it will be inverted. So reflected one, it will get turned out. So crest will become trough and trough will become crest. Is it clear? So free end and upright reflection. So the first was fixed end inverted reflection. The second is free end upright reflection. What does it mean? Like here the wave is going like this, okay, and here it gets broken, it's not carry on. So from here, some of them it's get reflected and some of them it's get transmitted. It will carry it. So after reflection, it will be in the same position. Look, so when a wave hits a free end, it reflects it back upright, not inverted. Crest remains crest, trough remains trough. This happens because the end is free to move, because we have not fixed. So if there is free end, there is none of the fixed end is there. So if there is no fixed end, it will get reflection back in the same position. So crest will be the crest, trough will be the trough. But if there is a fixed end, like this, it will become inverted. Okay. So example, a rope attached to a loose ring reflect the wave upright. So here you can see this is fixed, so it got inverted. Here it is free end. So free end, what happened? It goes and it's come back to the same position. The next is, describe wave properties like amplitude, energy of a wave, wavelength, speed, phase, period and frequency. So amplitude I already explained to you. It is the maximum distance of a particle's moves from the rest position. This is the rest position, correct? This line is rest position and it is going up, down. So maximum is the amplitude. The distance between two crest or two trough, it is called wavelength, correct? Then what is energy? Energy directly depends on the amplitude. So energy proportional to the amplitude square. Okay, so if there is a greater amplitude, more energy. Smaller amplitude, less energy. What is phase? Phase means a wave shows a position of a particle in its cycle of motion at a particular time. So phase means what you are talking about, like the phase of a wave, it shows position. It shows what? Position of a particle in that cycle of motion for that particular time, correct? So if the time is getting changed, like here you can say the phase is same, correct? Phase is not different. So phase will always show you the position of a particle in that cycle of motion. This relation I already explained to you, correct? These are the symbol which you can pause the slide and have a look into it. Now this is the important part. Here they are asking superposition of two overlapping waves. Superposition means when two waves are getting combined. So there are two kinds of combination of wave, and that combination of wave is called interference. This process is called interference when two waves are getting combined. So when there is an interference, it can be constructive, or it can be destructive. Two kind of interference it can be. So destructive interference means if this is the wave of crest coming here, and from here the wave from the trough side is coming. So when they mix together, this is the transition period, correct? When they mix, they will overlap, and once they overlap, they will cancel out, and you will get just a dot at the center, correct? It will go there, it will go there, so you will get nothing. So it is destructive. The amplitude will get diminished. They will cancel each other, correct? In constructive, they are in the same phase, crest, correct? So when they are crest, what is happening? It is coming, it is also coming. So let us suppose if its amplitude is 2 and its amplitude is 2. So when they are getting combined, the amplitude will increase. 2 plus 2, it will become 4, correct? This is how the transition will get, and you will get the greater amplitude. Different amplitudes, if they are having, let's say it is having 2 and here it is coming just with 1. So what happened? This 1 will be reduced with the final one and you will get the little one. So little, this is what? 2 minus 1. So you will get just 1, correct? So here they have given you one example. This is the incident wave of amplitude 3 centimeter. It is getting combined with reflected wave with down 1 centimeter. So what will be there? You have to minus 1 from 3. So 3 is the higher one. So you will be having the crest only at the top, but with 3 minus 1, 2 centimeter of amplitude, correct? Now the sixth objective is define nodes and antinodes and describe how they are formed. See, nodes is a point of standing wave when there is no vibration or displacement, okay? And antinodes is a point where standing wave where the vibration or the displacement is maximum. So here you can see there are the waves red and blue. So here the dotted one, this is the minimum points. These are what? Minimum points. No vibration, no displacement. So this is called nodes, okay? So 1, 2, 3, 4, 5, 6. So there are total 6 nodes in this diagram. Antinodes is the maximum one, this one. This is the maximum one, correct? So these are antinodes. So when you calculate it, you will get 1, 2, 3, 4, 5 antinodes, correct? So generally nodes means it's a destructive point where you are not getting anything. Antinodes is a constructive where you are getting something. So feature, vibration, nodes, no vibration, antinode, maximum vibration. Displacement, node 0, it is maximum. Type of interference, node means destructive, antinode means constructive. Position is standing wave. Node will be having a fixed resting point, but antinode is having a pointing largest movement. This is the largest movement, correct? So in a vibrating guitar, the fixed ends of the strings are notes and the middle part of the moving most is antinote. So in guitar you must have seen. So the fixed end of the guitar is actually, it is a node and the middle part is called antinotes. So there is a question based on the harmonics of a string. Okay. So for the string, you have to apply the formula of L. Okay. So always remember, if there is only one loop, means if there is a string and if you make some disturbance, it will go up and down, it will form a loop. So this is harmonic 1. Harmonic means the first one. Okay. Then harmonic 2 means 2 vibration. Harmonic 3 means 3 vibration. Means 3 loops. So first loop means 1 harmonic. Okay. 1 harmonic means 1 loop. This is called loop. Okay. 2 harmonic means n equals to 2 loop. 1, 2. 3 harmonic means 3 loop. Correct. So if there is only 1 loop, so 1 loop carries the length equals to lambda by 2. Always the wavelength will be half. Okay. For the 1 loop. So when I'll consider 2 loop, it means this is lambda by 2, this is lambda by 2. So total length when you have to calculate, it is 2 lambda by 2. Correct. Or you can say just lambda. Correct. So when there is 2 harmonics, this is n equal 1, and when n equal 2, this L will be equals to lambda by 2, lambda by 2. So it will be equals to 2 lambda by 2. Or just you can say lambda, 2 get cancelled. Correct. When there is 3 loops, okay, sorry, let me erase this one and let me make it clear picture. So when I'm talking about the 3 loops, okay, so this is lambda by 2, this is lambda by 2, this is lambda by 2. So total length L is equals to lambda by 2 plus lambda by 2 plus lambda by 2. So it will get 3 lambda by 2. Yes or no? So we can see that when n is equals to 3, it becomes 3 lambda by 2. So when I'll say n times, when there is a n number of harmonics, so n number of harmonics, what will be L? N lambda by 2. Means you have to multiply that n with lambda by 2. So this is the formula. Correct. So n can be 1, 2, 3, 4 like this. So this is just a formula. So when I say just calculate lambda from here, so this 2 will multiply with L. So it will become 2L by n. And this is n. So n means L lambda 1, lambda 2, lambda 3 like this. So this is the formula you have to apply for the string. Is it clear? So this is what I explained to you. First harmonic means 1, second means 2, this 3, 4, 5. And this is how you will get the wavelength. Lambda for the first one, it is just 1. So it is n times. Correct? So in terms of wavelength, what was the formula I explained to you just before? Lambda is equals to 2L over n. So it is 2L over n. So n is just 1. So it is 2L. Correct? When n is 2, so it will be 2L by 2. It is just L. Lambda 3 means this is 2L and this is n3. So 2 by 3L. Lambda 4, it is 2L over 4. Correct? So 2 times it will cancel out. You will get L by 2. Then lambda 5, 2L by 5. Correct? So all these values you can calculate. So first harmonic, 1 loop, 1 antinote, 2 notes. Higher harmonic contains more loops, shorter wavelengths. As harmonic number increases, wavelength decreases. These are the points which is required for MCQs. Because in MCQs they may ask you, like, if the harmonics will become higher, what will be the effect on wavelength? So wavelength will become shorter. Look, as the harmonics you are increasing, wavelengths are getting shorter. It was before 2L, then it becomes L, and then it is become 2 by 3 times, then it becomes half, then it becomes 2 by 5. So L is decreasing. Yes or no? Sorry, wavelength is decreasing. Lambda is decreasing as the harmonics increase. Harmonic number increases, wavelength decreases, correct? So the next is we have to define sound as pressure oscillation that is transmitted through matter. Explain that sound is a longitudinal wave that has frequency, wavelength and speed, correct? So in this case we have to do that. So I'll explain this topic in part 3. Okay.